Hi everyone, Niall here. Welcome back to the 8020BIM channel. Today we're going to talk through how users can take something like this, which is an Excel point data spreadsheet, basically from something like a Lidar map or just a survey that's not a drawing-based survey, and change that information into a workable surface within Civil 3D. This is part one of a multi-part kind of mini video series. I'm going to have two more parts after this. And what we're going to go through here is basically how to take in this point data, so that file has in excess of 10,000 points, to create the surface that you see in front of you in Civil 3D. Then in the next video, we're going to talk about how this surface can be transposed into Revit for accurately draping, let's say, a Revit topography over the topography that's been generated. And finally, in the last part, we will discuss how maybe you can cut out the middleman of Civil 3D if you don't mind being a little bit inaccurate and taking the point data directly into Revit, okay? But in this instance anyway, we're going to go through the process of taking the Excel information that we had at hand, changing the Excel information into a workable format, and then migrating it into Civil 3D for use for your site development, okay? So all the resources that you see in this are available from the Buy Me a Coffee support page down below if you want to actually go ahead and get them and work alongside them and you know, use the same information for your own development. Outside of that, and the second link down below, we have a Discord channel. It's a community channel. Everyone's very friendly over there. Pop on over if you have any questions and we'll do our best to answer that. I'm not a Civil 3D expert, but I just have to do this as part of my day-to-day workflow. Finally, as always, if you like this, you know what to do. Like, comment, subscribe, all that jazz as I adjust the chair, and I won't take up any more time. I get straight into the video and I'll show you how I think this should be done anyway. All right. So for step one, the first thing we need to do is to format the Excel document in such a way that Civil 3D can draw down the point information, okay? So looking on screen here now, you can see the file received. And what this is a point data spreadsheet that is derived from a Lidar exercise whereby the Lidar maps the ground and just gives you the value of the point information, okay? This file has in excess of 10,000 points, okay? So what we don't want to do is use something like a ranged denominator, let's say, within Civil 3D to define the points we're bringing in, because it's far too many points for us to associate the ranges that we want to bring in. What we want to do beforehand is to make sure that the format of the Excel data is in such a way that the program can read it, you know, as is without any kind of interference. So looking at the headings here, we have X, Y, Z and accuracy level on top for the headings, okay? And X is our eastings, Y is our northings, and Z is our elevation above the survey point or sea level in this instance, okay? And our accuracy level is the degree of accuracy. So for the LiDAR exercise that we acquired here, it's 0.25 or 250 millimeters kind of range of accuracy. So this is much more for early project development, kind of understanding pricing for cut and fill exercises and that kind of thing, okay? So what we want to do is to ensure that all we have is the data information, that the data points that we need, okay? So looking at what we have here, the first thing I'm going to do is I'm going to select our column for D for the accuracy level. We don't need to report the accuracy level. It's going to interfere with the figures for Civil 3D. So I'm just going to delete that. And then our first row there, I'm also going to delete. And quite simply, what we're left with is our eastings, northings, and our relative elevation above sea level. And this is the format that we need for Civil 3D or Revit or any other CAD utility to read the information off of. Finally, the last thing you need to do is to ensure that you save the file as a .csv or comma separated value file. And that's for the software for Civil 3D, CAD, Revit, and so on, to be able to understand the separators between the values for each point, okay? And you'll see later on in the video in Civil 3D, I can actually define the type of delimiting or spacing requirements that I want the software to read. So in this instance, .csv is my recommendation, and it generally is my recommendation because it seems to carry through all the programs. So Revit recognizes .csv points, CAD recognizes .csv, Civil 3D recognizes .csv, and so on. So export as or save as a .csv format, okay? So that was step one, which is knowing how to format your Excel documentation prior to bringing it into Civil 3D. So step two, I want to talk about how to create the initial surface within Civil 3D. So this is basically the instigating steps to bring in a surface or a thin surface in this instance, into Civil 3D that then the point data will inform, if that makes sense. So what you do is you assign a surface to the model environment first, and then you bring in the point data, which will control the various contours and points on it, okay? So looking on screen here, okay, this is your standard opening screen for Civil 3D. And the first thing I want to highlight to you is when you're taking in something like a Lidar point file like this, or any point file generally, okay, it is best not to use a template that you already have pre-existing unless you really understand the quality of your templates and how they're set out, okay? Because what we don't want to have is an instance where the template is doing a unit conversion or something akin to a scaling or something like that automatically, just because of the nature of the definitions within the template. We want our data to come in raw and unaffected, okay? So in this instance, on our get started on the drop down, I'm working to metric, so I'm just going to select no template metric, okay? And this will open a blank file that doesn't have any templating that can negatively impact the units that are coming in, okay? Then you'll see this window, okay? And in our tool space, okay, I want you to go to Prospector. And on the left-hand side, you'll see that it's called Drawing 2 at the moment, okay? And you can see that we have surfaces. And what I want to do is I want to right-click on surfaces and create surface, okay? And when we create surface, you'll get this dialog, okay? And we can define the type of surface we're going to create. So in this instance, I want to create a TIN surface, okay? Tin surface. And then we can apply the layer. So obviously, anyone who has a CAD background understands that you do not draft on layer 0. That's like a big, stay away from def points, stay away from layer 0. So we're going to create a new layer for this, okay? And you can see that we don't have any layers present. So I'm going to create a new layer, okay? The layer name, we're going to call Topo. Color, I'll leave as white, line type continuous, line weight default. You can obviously change these to whatever sort of layering convention you'll be using internally, okay? So if you have your own CAD standards, or if you're following some sort of BS 1192 CAD standards historically, you will know what layer convention you want to actually generate this on, okay? So pretty much everything here I'm just going to leave as. I'm just going to call it Topo, okay, just for clarity, okay? And I'm going to press OK, okay? And then you can say that the base layer is base layer name, sorry, apologies, is Topo, okay, modifier. I don't want to put in a modifier value at the moment, there's no need, but you can put in a prefix or suffix if you wish, okay? And you can see that the final name is there, okay? So I'm just going to press OK. Then outside of that, we're going to name the surface. So here I'm just going to say sample surface. And in the description, I'm just going to say tutorial surface. Okay. One day, I swear, I'll be a cleaner typer. And then we press OK, right? And what we've done here now is we've actually introduced a surface into the model environment within Civil 3D, okay? But there's no geometry assigned to that surface. So the next step in step 3 is to show how to bring the point data in so that the surface acquires the point data and starts to generate the geometry, okay? So that was step 2 on how to create the initial surface in Civil 3D that you can then append the point data to afterwards. So in step 3, we're going to bring in the Lidar Excel CSV point data into Civil 3D and append it to the surface that we've actually input into the project, okay? So you can see now that we have a drop down next to surfaces here, okay? And when we expand that drop down, you'll see sample surface, okay? And you'll see that we have masks, watershed, and definition, okay? And on the definition, we also have another drop down. So we want to take that drop down there, and we can see we got boundaries, break lines, contours, all of that, okay? But what I want to highlight to you is the point files here, okay? So if we right click, we can press add on point files, okay? And here you can see that we have add point file. It's a window dialog that is opens. It's a dialog window, sorry, that opens, okay? But now we can direct the model environment towards the point data that we want, okay? So I'm going to press the plus here, okay? I'm going to go to my desktop. I'm going to go to 8020 BIM conversion CSV. So this is the file that I saved out after we went through how to modify the Excel for the formatting, okay? And I'm going to press open, okay? And if you remember, we had the format as eastings, northings, and our respective elevation, okay? So that means that when we specify the point file format, okay, in the second section of the menu here, we know that we want the easting, northing, and the elevation in that sequence. And we also know, because it's a CSV, it's a comma separated value, that we need to ensure that we're selecting an option that's comma delimited, meaning that the spacings are derived from the commas between the values. Okay, so very luckily for us, the first option there, ENZ comma delimited, is eastings, northings, and our elevation comma delimited. And you can see that that works because, first of all, our file name is recognized as a suitable file format. Okay, and when we select this point file format, you can actually see in the preview that the formatting is exactly the same as we presented it in our Excel environment. Okay, in the advanced options down here, then I just want to highlight to you that we have do elevation adjustments if possible and do coordinate transformation if possible. I tend to leave the first one on and the second one off. Okay, we don't want to do any transformations at the moment, hence why we didn't allot a template file at the start in case it actually undertook some sort of transform that we didn't want. But the elevation adjustments, it kind of tweaks to find the median between, let's say, egregious values that spike. So let's say you have something like a very, very dense object that is similar to the ground profile that is in the vertical plane, like a bollard or something like that. Using the elevation adjustment there, we can average out that so that we're only getting the surfaces. Okay, so pressing again, you have to understand that for the Lidar map in particular, we're not working to a degree of accuracy that you would from a 3D survey that's carried out on the ground. Okay, so I'm going to press OK, and we have brought in our data points there. Okay, and after that, if I zoom extents, you can see that we have this boundary. Okay, and it doesn't look very impressive at the moment, but if I go to the view cube and I click on the southwest corner here for argument's sake, you will see now that we have a fully profiled surface there that we can begin to develop our model data off the back of. Okay, but this isn't presenting in the way that we want it. Typically, we like to see contour lines. We might want to see the point data independently, depending on the density of the points. We might want to see, let's say, the gradient as a kind of an elevation heat map or a color scheme. So what we'll do in the next part is I'll show you how to change the presentation of the Civil 3D environment to show the contour information and that kind of thing, because that is the default, let's say, output that we're looking for. Okay, so that, I believe, was step 3, which was to bring the Excel CSV data into Civil 3D and append it to the surface that we'd created. So step 4, we want to discuss how we can change the presentation styles in Civil 3D to show the likes of the contours and the elevation heat maps and our point data and that kind of thing. Okay. Just note that the reason I'm keen to show this step, although this isn't a prerequisite because we already have the surface in and we know how to bring the surface into the environment now, is because if we want to bring it into something further, which is going to be the next part of this this video series, I'm going to take this data and bring it into Revit and generate a Revit surface from the same. We want to ensure that we're presenting the information in the way that we want to transpose that information into the other design software. So in this instance, I definitely want to see contours at a minimum. Okay, so on our screen here at the moment, you can see that we have the surface. Okay, and what I want to do is I'm just going to navigate down to the top-down view. Okay, and you can see all we have is our boundary line. Okay, in the top-down view. Now, Civil 3D is very interesting because you can actually change the presentation depending on the model view type. Okay, so although we're in 3D space at all the time, when we're looking down, it recognizes in a plan. When we're looking, let's say, in the elevation, it recognizes that it's kind of almost in a sectional view. And when we're in the 3D kind of isometric or orthographic views, depending on the way we have the views set up, it recognizes that we are in that particular view style as well. Okay, so what I want to do is in the tool space again, I want you to go down to settings. Okay, and on settings we have surface, and on the surface I want to expand surface and surface styles, and you can see that we have standard here. Now again, had we templated if we were working to a template that we understood to be reliable for this use case, we could have a surface style already standardized within the template, and therefore you wouldn't need to make any edits at this point. Okay, But again, it depends where your organization is. At that, a lot of organizations don't really have high quality civil 3D templates so far as I can tell. Okay, so going to surface, we're going to double click standard. Okay, and what I want to show you is the following. Okay, so when we go to display, we have all of these are not layers. Okay, as such, you can see that they're all applied to layer 0. But what we have is a presentation of elements more so than anything. Okay, and you can see that we have the view direction set as plan. So in the view direction set as plan, I want to show our points. I want to show our major and minor contours. I want to show the user contours. So let's say if users want to derive their own contours, I want them to be presentable. And I want to show the elevations, and this is the elevation heat map. Okay. And I'm going to press apply, and I want you to pay attention to what happens in the background here. So now you can see that we have contours visible. We actually have a color grading to show the respective elevation of elements. Okay. And we have basically a red mesh. All right. And what I'm going to do is I'm going to press OK there, and I'll show you. Because we have so many points, I'm praying now that this hasn't crashed. This isn't necessarily the cleanest process sometimes. If it has, I'll ask you to bear with me, and I'll come back in a moment. And we appear to be back. So just so you know, I'm working over a remote connection to another PC, and anyone who's ever worked in AutoCAD applications understands what the remote desktop protocol does to the graphics processing. It's not like working in Word or something like that. Anyway, so you can see on screen here now we have basically what is red grid, and what each intersection of that grid is basically, this is just the size of the point information. So what you're seeing is the red crosshairs of the points across the thing. Okay, so I actually want to change that because I think it's too overbearing on the view, and I'm actually going to turn off points. Okay, so I'm going to turn off points here, and I think in this instance I might actually turn off the elevations as well, just to save on a bit of processing power. Okay, so I'm going to press apply, and you can see now that we have our contours just in place. Okay, but that doesn't actually change the presentation of everything. Okay, because when I go to the southwest corner again, okay, you can see that it flips back its orientation. It's only showing the triangles. Okay, so going back to our surface styles, okay, and double clicking standard, we changed the view direction. Okay, see the way, so we've got plan, model, and section. On the model here, okay, you can see that all that's selected is triangles. So I'm going to turn back on our contours, and I might even turn off triangles just for a moment. Press apply, and you can see all we have is our contours there. Now the contours don't look as well as one might hope, because the density is quite low. So in the next part, what I'm going to do is to show you how to control the presentation of things such as contours to meet the intervals that you require for your export into whatever program you have. Okay, so in this instance, I know the intervals to be too wide. I want to significantly reduce the intervals. So in the next part, we're going to go through that. Okay, so that was part 4, which was how to change the presentation of the various styles within Civil 3D on a per view type basis, if that makes sense, so that you can present the data in a way that's coherent with your outputs. So back for step 5, and what we want to do is discuss how you can change the presentation of the contours within Civil 3D so that you have tighter or greater intervals or what have you. Okay, so closing this window. Okay, if we go back to our settings tab under the tool space, and if we expand surface styles, we go into the standard dialog that we were in previously. Okay, and along the top toolbar here, you're going to see various tabs. We were in the display previously, but in this instance, we want to go to contours. Okay, and you can see we've got contour ranges, 3D geometry, etc. But what we can do here is expand contour intervals, and you can see that our minor interval is 2 meters and our major interval is 10 meters, which is excessive, let's say. So I'm going to say that our minor interval is going to be 0.5 and our major interval is going to be 2.5. I'm going to press apply. Okay. And you can see that what happens automatically with the contour intervals, and this is just good practice, is it multiplies it by a scale of 5. Okay, so your major interval is every 5 of your minor intervals, and this is just a standard that's been around for as you know, for a very long time. So looking at our minor intervals again, I'm actually going to change them to 0.1. Okay, which is getting very narrow, I admit, but you can see that we have a huge density of points then. Okay, so this is how you can control the presentation of your contouring within Civil 3D for output to your CAD or your Revit application or what have you in the aftermath. Okay, so pressing apply there, I'm going to press OK. And now you can see that we have a density, and that density isn't view based now. Okay, so we've defined that presentation style for all views on this surface. So going to the top, you can see it doesn't roll back to the earlier contour intervals. Okay. So yeah, that was step 5 on how to change the presentation of the contour information in Civil 3D. Okay. So that about wraps up the video. I think what we're going to do for the next one is kind of transpose this information into Revit, because this is more of a Revit-centric kind of BIM channel. But I wanted to go through this in a bit of detail because we can take point data directly into Revit, and I'm going to do that as a tertiary video to this and the following. But Revit has some problems with kind of, let's say, evening out the point information. And you often have to go and manually edit the points back to what they should be after you've brought in the Excel data. So that's not every point. What kind of happens a lot is that you bring in the Excel data into the Revit environment, and maybe 9 of the 10 are correct, and then you'll have these kind of weird kind of anomalies throughout it. So I prefer going through Civil 3D because Revit will basically directly drape over the Civil 3D surface that you've generated, and you know that the point information is correct. Okay, so that sums up the video. As always, if you found it useful, like, comment, subscribe. All the resources are available for this in the first link below, over on the Buy Me Coffee support page. Head over to the second link, which is the Discord channel, if you want to ask any questions or run through this. I am not a Civil 3D expert. I don't claim to be a Civil 3D expert, but maybe you can come over there and teach me a thing or two either. I'm Niall, this 8020 BIM. Hope you enjoyed this. We'll see you for the next video in this series, which will be taking the data across into Revit to generate the surface in Revit. And yeah, take care of yourselves, and we'll talk to you again soon. Bye-bye.